Welcome to This Explainer. Today, we're diving headfirst into quantum physics complete explained, and we're going to unpack the microscopic rules of the universe. Now, I know for a lot of people, just hearing the words quantum physics sounds incredibly intimidating, right? It sounds like something reserved only for chalkboards in dusty university basements. But today, we're going to prove that it's actually actively shaping our reality and the technology we literally rely on every single day. We're going to break the whole thing down step by step. But first, let's kick things off with this amazing quote from Nobel laureate Richard Feynman. It's absolutely crucial to put this out there right away, just to lower our defenses a bit. Because, look, if a literal pioneer of quantum electrodynamics was completely confused by the strange behaviors of the subatomic world, it is perfectly okay if we are too. The goal here isn't to walk away with a PhD, but to really grasp the core concepts that define this fascinating field. So, to make this dense subject totally accessible, here is our roadmap for today's explainer. Section 1, Classical versus Quantum Physics. Section 2, The Bizarre Quantum Rules. Section 3, The 270-meter Teleportation Breakthrough. Section 4, Real-World Quantum Applications. And finally, Section 5, The Ethical Quantum Framework. All right, let's jump right into Section 1, Classical versus Quantum Physics. We're going to look at the massive paradigm shift that changed how we view the mechanics of the entire universe. You know, there's just a stark contrast between these two models of our universe. Think about the predictable, clockwork universe of Isaac Newton's classical physics. Down there, we're dealing with macroscopic objects, things you can see and touch. If you know the initial state of a system, like, say, a thrown baseball, you can predict exactly where it's going to land with absolute certainty. But quantum physics, it throws a massive wrench into all that predictability. It governs the microscopic realm of atoms and subatomic particles, where things are probabilistic, not deterministic. Energy exists in discrete little quantities, or quanta, rather than continuous flows. And because of things like the uncertainty principle, we simply cannot measure all the properties of a particle exactly at the same time. Actually, the mere act of measuring a system fundamentally affects it. How wild is that? Moving on to Section 2, the bizarre quantum rules. Now that we know quantum physics governs this fuzzy, probabilistic subatomic level, let's dive into the bizarre rules that operate down there, because this is where reality gets truly strange. Take the concept of superposition, for example. Before a measurement actually takes place, particles don't just have a single fixed location or state. Instead, they exist in these abstract probability distributions, mathematical descriptions that we call wave functions. Think of a spinning coin in the air. It's a blur of both heads and tails simultaneously, right? Well, a quantum particle is a mix of all its possible outcomes at once. It only lands or collapses into a single definite reality the exact moment it's observed or measured. And the weirdness definitely doesn't stop there. We've also got wave-particle duality, where things like light and electrons exhibit properties of both waves and particles, depending entirely on how we measure them. Then there's quantum entanglement, where particles become inextricably linked, immediately sharing information no matter how far apart they are in the universe. But the really crucially important concept here is quantum tunneling. It sounds like literal magic, particles passing through physical barriers they shouldn't have the energy to cross. But it's essential. It's the exact phenomenon that allows protons to overcome their mutual repulsion, fuse together, and actually power the sun. Without quantum tunneling, life on Earth simply wouldn't exist. So let's get into Section 3, the 270-meter teleportation breakthrough. These concepts, superposition, entanglement, tunneling, they all sound a bit like science fiction, but let's look at how they are actively being proven in the real world right now. 270 meters. This is the exact distance an international research team recently managed to teleport a photon's polarization state across an open-air link. Now, to be clear, we aren't talking about beaming humans aboard a starship here, but they essentially transferred the quantum properties of one photon to another physically separated photon using that principle of entanglement we just talked about. And what makes this so groundbreaking is that they did it between independent devices, not just from a single isolated source. Let's look at how this all came together across a massive European collaboration, because it took a solid decade of strategic planning. They had to engineer specific quantum dots in Linz, perform some seriously advanced resonator nanofabrication in Würzburg, and finally conduct the teleportation across a 270-meter free space optical link connecting two buildings at the Sapienza University of Rome. By successfully transferring this state with over 82% fidelity, they basically proved that quantum information can reliably travel between completely independent quantum emitters. This brings us a huge step closer to highly secure quantum networks and the eventual reality of a scalable quantum internet. That brings us to Section 4, Real-World Quantum Applications. Because teleportation and future quantum internets aren't the only use cases. Let's explore how quantum principles already invisibly power our modern world today. It's truly fascinating to realize that without an understanding of quantum properties, much of the technology we just take for granted wouldn't even be possible. The very device you are using to watch this explainer relies on semiconductors, and those only function because we understand how electrons behave in quantum energy bands. Lasers utilize the stimulated emission of photons, MRI machines in hospitals, the solar panels on our roofs. None of these things would exist if we were still relying solely on classical Newtonian physics. It's pretty mind-blowing when you think about it.
And as we push forward into the era of quantum computing, researchers are leveraging entanglement for incredibly advanced communication protocols. For example, take quantum teleportation, which uses one unit of entanglement, an EBIT, to transmit one quantum bit of information, or a qubit, by sending two classical bits. Well, superdense coding achieves the exact opposite aim. It uses that same one EBIT of entanglement to transmit two classical bits using just a single qubit. This amazing ability to manipulate quantum states is fundamentally changing how we think about data density and secure communications altogether.
Finally, let's head into Section 5, the ethical quantum framework. Because with this immense, world-altering technological power comes some seriously heavy societal responsibility.
A comprehensive report out of Stanford Law School highlights a pretty sobering reality here. They presented the 10 most pressing societal risks of quantum technology. And these aren't just technical hurdles. They are urgent geopolitical and ethical threats. A powerful enough quantum computer could potentially hack global encryption, which would destabilize economic systems and data security literally overnight. The report impartially notes risks of increased inequality, a looming quantum divide between nations, and the very real potential for a distorted balance of global power if a quantum arms race goes completely unchecked.
So, to mitigate these massive risks, the global quantum community is urgently calling for a legal and ethical framework. Researchers and policymakers are proposing core guiding principles to ensure the technology remains human-centered and sustainable. We're talking about legally safeguarding human rights, mandating technical robustness through rigorous audits, and strictly complying with privacy laws. Perhaps most importantly, it's a call for international laws to proactively prevent environmental harm and strictly prohibit a destructive quantum arms race. Basically, it's about establishing the rules of the road before the technology fully accelerates out of our control.
Which brings us to one final, profound question. As quantum computing power inevitably merges with advanced artificial intelligence, a lot of experts predict an unbounded intelligence explosion that will completely reshape humanity and the Fourth Industrial Revolution. The science is progressing whether we're ready or not. So we really have to ask ourselves, are our legal, ethical, and societal structures genuinely prepared for a world where the bizarre rules of the quantum realm become the primary engine of human progress? It's definitely something to deeply think about as you navigate our quantum-powered world today.